Okay, we're live. Funny, I'm not seeing it working. Hold on. Oh, there we go. Cool, this works. We have a lot of stuff to do. So I guess let's just get started here. First of all, quick check on Puffer. Lots of stuff is down, it seems. There we go. Almost at 800. That's awesome. Let's go check WANDB. So there were some experiments from last week that I just didn't check on. I got distracted because of the 50K. Okay, so right here, yeah. Here we have all of our runs. These were the baselines that we set. So I suppose we should double check these versus the original PPO paper. Of course, we're actually training way, way fewer time steps than they are. So we'll have to take that into account. Let's see. How are we going to do this? Okay, let's do this. And then, so this is Qbert. Qbert, they get, what is their one? Which color? Red. So in 15 million steps of Qbert, we are at 2600. I think that we do better than them here. It's hard to say because this is like a really long training run, so we should probably do some much longer runs. I'm just trying to get a ballpark of if we did well or not. So Beam Rider, we've got 1500. Yeah, we crushed them in Beam Rider here. This is like 160, 200 million step run or something. So Beam Rider is good. Breakout? I think Breakout's bad, right? 115. 115 and only 10 mil is actually not terrible. Yeah, we're fine here. And let's see. Qbert. What do you say, Enduro? Oh yeah, we crushed them on Enduro. Where the heck are the rest of them? Sequest is not there. Wait, what? Oh, well, this is Enduro twice. And then 1, 2, 3. What happened here? Something weird happened. Hold on. So we're missing Space Invaders and Sequest. I don't know what happened here. Assuming that this just didn't, yeah, this just didn't run. Something weird happened. Whoops. Okay, so we'll figure that out. But these look so far so good. We should queue up some of those. What? Put like individual points on here. This is the UI screwing up, right? Okay. So Let me see if I can figure out why this is, what has happened here. And then what I would like to do is I'd like to just run a longer experiment with some of these. We also have the MOBA results. I posted these on Twitter yesterday. I didn't really get a chance to look at them too much. But we actually do have increasing ELO over time. So that's quite good. Okay, I think what we're going to do then is let's figure out what's wrong with this, and then we'll do the C stuff, and then we have other things to do from there. We have a whole bunch of projects that need my attention today. So this was the MOBA sweep. We can just run this. We can just run this for longer, right? Because we're not going to get to this otherwise today. Yeah, let's just do that real quick. So on this box, we will just do carb sweeps. Oops. Just do a whole bunch of runs here. And hopefully it will start doing longer runs over time as well. We will see about that. Okay. And let's check puffer box 1. And we'll see what went wrong here. Hey, Nathan. Let me get this off of the chat. Welcome. How's your project going? Okay, so something weird happened here, right? Kyung started using my box for Majoko. Okay, Kyung, that's fine. I'll let you use this box for a bit. Using it still? Doesn't have anything running on it now. I did tell him he could take any box. I didn't expect him to take my box, but okay. Wait, is that message from today? What are you studying at Stanford? I'm a Stanford alum. I graduated in 2019. Yeah, that's from today. Okay. I finished AI, my undergrad in CS AI in 2019, and I just finished my PhD at MIT a few months ago. So now I'm doing this stuff. Finish your way on here. One of the profiles you displayed. Oh, that's funny. Where? I don't know where I had that. It's probably old from because maybe something still has my old email on it or whatever. But yeah, I'm an alum. I'm getting a pretty good Pong agent, but it takes a while. Got to tune some hyperparams. Just do it automatically with carbs. Carbs will just do it for you. You can even use if you want some defaults to use. Here, I'll give you them. This is a cool thing about being able to do this, right? As I can just go here, I can say, look at this one. This one's not actually as good as it should be. I don't know what happened here. It solves it in 5 million steps. Oh, wait, maybe it's that it's really fast in wall clock, right? There's the wrong axis. Yeah. Okay, so this is like 2 minutes or whatever, a little longer. We have runs that are like sub 90 seconds. So this one is not amazing, but here, you can take these parameters, Nathan. Starting point. Oh yeah, there it is. This has my old Stanford email on it. Should change that. Yeah. Let me look at them to make sure that they're actually kind of reasonable for the Pong. Let me just do a double check for you. They like pass the initial. You also have to check the env parameters here. It's frame skip 4. Is this CNN obs and score reward? Yep. It's in the dev branch. You can check exactly what I do with the Atari. With like the Atari env binding in there. You have all the params in here and 32K batch. These are mostly reasonable looking. It's a really large number of updates on stale data with a small mini batch size is the only thing that looks a little weird. But yeah, this apparently does quite well. Really, we would like to be able to average over random seeds, but WASM doesn't make that easy. Plain features now with tiny MLP. That's fine. You can add an LSTM for free. Puffer will just do that for you. I usually recommend that. Two stars off 800. Let me think what I want to run here. Atari mode. Train. Okay, well, Kyung did some stuff here, so I'll leave this alone for now. You can use this box today. Welcome. 5x lower SPS on my little CPU with the yeah, you need a GPU, of course. How's the env speed though with Pong? Progress from yesterday? I have sort of thought about it, and I think it is worth spending a little bit more time on Onyx. I was just doing a couple things to start some runs by default. Also, I should just double check that I'm not missing anything here. I missed a message. 1 second. Is it enough? That's per agent done. Let's stay done. Do that. Okay. Autotune gives me 40 million steps. What? Well, that's freaking good. Oh, it's Pong, of course. Pong should be faster than a lot of stuff, yeah. Especially if you're just doing observations like a small feature. Okay, yeah, cool. If you're training on 500K to 1 mil SPS on CPU, you should literally be solving that environment in like a few seconds. Just use the carbs integration, Nathan. Like, with as fast as that NVIS, in 20 minutes you'll have a full suite. Like, you can just run 500 experiments. All right, we should start on the C and the Onyx stuff for today, because that's what the stream title is, and also it needs to get done. Tiny thing. Yeah. There are more integrations coming so that you can automatically scale your net up and down. I got to do that as well. C and Onyx stuff. Yeah, like it ends up being worth doing, I think, just a little bit more. I realized that there was like a flag that I kind of ignored from here. Where is it? This thing gave me a flag to compile right here. Where is it? Are you going to migrate all your Python to C eventually? Not necessarily. This is just an experiment. The only thing that would cause me to migrate all the Python to C would be like if I finish this project and I post like play Snake against 1,000 trained AIs in your browser, right? And like that blows up on Twitter and gets me a huge amount of exposure for Puffer. Then yes, I would consider doing it. Otherwise, this is just like a fun test. Okay, so this is what we wanted here. Build. I'm trying to remember where we left off with this yesterday. I think that this was not working, right? So if I did this, it works. Yeah, for folks like that are doing stuff in Python, there's literally no performance reason to do C instead of Python. It's just, I'm messing with some WebAssembly stuff is all. There's no performance reason to prefer C. Build temp. Trying to remember how I structured stuff here. Build game HTML. Okay, so this one works, right? And what I wanted to do is I wanted to add the debug information. Which was right here. Allows you to debug your C directly in the browser, right? Oops. Okay. And I remember this not working. So... Okay. Okay. Let's see what it has for me here. It has exposed functions, malloc free. Wait, so let's put these down there. And then this source map thing doesn't work, right? So we have this, we have this. Dash dash source map base. Okay. So it's a different flag now. Let's see. Demangle support is deprecated. Okay, what happens if I run it though? Okay, so this now runs. Is there anything in here? What? Oh, look at that. This didn't come up before, right? Resetting, reset complete. Okay, I get prints now. This is... Yeah, I get prints. Okay, perfect. We might actually be able to do something with this. So... Because I should actually get bugs. I should actually get error messages in the browser now, I think. Oh, right, I forgot. It also takes a long-ass time to compile this. Ugh. That's okay, though. EMCC supports C cache? No idea. What would the flag be? I don't know what it's building either is the thing, because, like, I thought I already have EMCC built. So it should just be linking to it. I don't know what it's doing that takes this long. But I do remember it does actually eventually build. It just takes a couple of minutes. C cache. Oh, maybe I can just do that. For carbs, should I do dash dash mode sweep carbs? Yes. And then do I need to specify all the sweep params? Yes, but you also get some of them from default. So if you look at like the way that, yeah, you do need to specify those, but like if you look at the latest dev branch, I have like a lot of them are already set with defaults in the demo file, and like it'll just infer the min and the max from your range param. Like check like the Atari or whatever, the new examples there, because like most of them can just be inherited and you just have to edit a few. Running limited binary and optimizations. Ugh. If we actually get this to work though, you know how awesome this is going to be? We're going to have a 400 line demo that's pure C that just runs, runs in the web. 100% client side. Meaning I won't have to deal with anything else. I can just ship like 2 C files or 1 C file, whatever. And it'll run local, it'll run where whatever, I think. Actually, I don't know if this runs local because I'm using like WebGL builds of Onyx. I'll have to see about that. We'll see whether this is as appealing as just implementing some networks. The main thing is if I don't want to have to write my own conversion layer from Torch to like something else. Does tinygrad have a C API? Oh wait, they have WASM C backend. Wait, they have C code generation? Where's their C code gen? Invest with your PRs is funny. I'm looking to see because they say they have web GPU, and if they do, this could be simpler. They say that they have this. Where is it? Dang it. Freaking docs. Where are these? tinygrad has WASM, but like where? I wish I could find this thing. WebGL. Is this it? Hmm. Compile. Man. Love to know how this frickin' works. This is JavaScript. They say they have it, but I can't find where. I don't know. How's this thing? This thing is run at least. Okay, so this thing breaks as expected. Game.js. The fuck? Oh, come on. This doesn't give me a proper error at all. Yeah, okay. We're just gonna do... I'm gonna go nuts if I have to do this all day. So what we're gonna do instead is we're gonna do something I know will work. This is what I said last time. We're just gonna try to like make like an MLP for now run in... we're just gonna see if we can get like an MLP to run locally. Let me start on this. So here's how this is gonna be different. What we're gonna do is... I just heard I can't work with stuff that's that heavy and shitty. It's just like, no, not doing it. Okay, so Torch doesn't have default. Oh, you found it? Let me see. Okay, so explain. What? in order to get this to work, I would need to make an export from PyTorch to tinygrad, and then I would need to write like a version of this for tinygrad that then exports it to C. Yeah, I don't understand how the fuck I'm supposed to do anything with this. Well, I mean, what am I supposed to do? This is like, like... It's cool that this works, but this is not in any way that I can, like... There's no way that I can, like, oh, cool, I can just slot in tinygrad to use as a web GPU backend. I mean, of course, like, they say that they've put basically no effort into that because it's not what they're doing at the moment. Yeah, I need to do torch tinygrad anyways. I might as well just do torch to C, right? Because, like, that's what they're doing. They're just manually doing tinygrad to C here. So what I was going to do, which I figured would be less making me want to fucking die on a Friday, is... do this. State.py, what's this? Oh, okay. Is this general? They actually have a load torch? But they still don't have an export from tinygrad, right? Like, they say tinygrad has WASM, but they don't generally have WASM, right? Like, they have, like, specific examples for which they've manually exported to C, right? Or do they actually have, like, a way to do, like, tinygrad model to WASM? Because if I can just do torch to tinygrad and tinygrad export WASM, then I'll gladly use that. To understand how efficient net. Well, the efficient net converter was... Like, I would still have to manually make one of these. Because, like, look. Unless this is just input reading. Empty plus... Oh, this is as empty plus weights. Image library. C program equals prog. Wait, export model. Wait, what is this? Oh, whoa. Is this it? That might be it. Somewhere here. Onyx? The Onyx was shit, though. I tried that. How's there no underscore init in here? Extra dot export model. This is JavaScript, isn't it? Not C? This here? 313, you say? GL... What? Only web GPU. Can you tell if there's C code gen here, or if this is like JavaScript and WebGL shenanigans? Can I just export this to C and compile the WASM? That'd be great. Export model web GPU. Export model Clang. That's promising, right? Oh, this is C. This is C. So... do we want to make a quick little demo script with this then? Let's see. We'll try it. Let's try it. You're right. That this is worth... if I don't have to write my own C code gen, I'll be happy. So... yeah. Where are we at the moment? Snake. Do I have snake model.pt in here? No. Okay, so now we have test grad export.py. Okay, PyTorch model torch.load snake model.pt for torch model. Okay, install. I don't want to lose this window. We're screwed up. I need the history. Okay, I gotta hand it to George Hotz here. Having a small package that actually fucking just installs instantly, top tier. From tinygrad.extra export model. And then where was the export torch thing that we had? You linked that before, didn't you? Torch load. tinygrad.nn.state. From tinygrad. Oops. State torch load. Okay. Oh wait, it loads just the model, so I just need to give it snake model.pt. I might want to, should I move this to CPU first? Well, we'll see if this works initially. Okay, and now we have export model, clang, which it calls this for us, I think, so we can just do export model. What's star inputs? We should just be able to do model, and then target is clang. And what's this return? Program input output state. Tensor names, you can probably do nothing. Let's see. Dummy takes no arguments. What? Dummy takes torch load is, hold on, let me grab it. Fuck, this is so dense. Code is actually fine. I wish you would add some spaces to it, though. Holy hell. Open torch pickle. Wait, PT, is PTH different from PT? Was it all the same? Yeah, it's just people using whatever, okay. Is it expecting the state? Maybe, is it expecting like state dict or something? Let's see, what does this give us? Is this expecting us to have a pickled model or a state dict? It would have to be a pickled model, right? Torch load. This looks like it needs a state dict, right? Yeah, but look, this torch load, this is fetch. Wait. No, hold on. Yeah, okay, so it's fetch of state dict. Pickled torch class. Yeah, well, that's what I should have already. Was there... I'm just wondering if there's direct code gen for something. Doesn't look like it. What's the error? That's the thing. It's like not a reasonable error. Torch pickle. It says is zip file. It's not a zip file. What? Oh, camera. My bad. So this should not be a zip file, right? It's the else statement. 192 right here. Wait, what? LF tar. Yeah, but isn't it calling this one? It says state line 192. Good point. Looks like it's the same. Do they have tags for their releases? Doesn't look like it. Oh. I assume it's this. And this is still the same. I mean, we can just check, right? Yeah, it's the same, man. It is on the zip file. Why does it think this is a function? Wait, function string. I guess the file name maybe, not function. Maybe it needs to be named .pth. Maybe they have that hard-coded. Ah. I think they have it hard-coded to the extension. Huh? Maybe not. Let's see. No, this says this is a zip file. So I guess it's treating this as a zip. Try to unzip it. Apparently it is just a zip. That's weird. So I guess that makes sense. I don't know why they would have a custom extension then, but it's kind of deranged. For PyTorch. I know jar is Java archives. Is it literally just a zip though? Okay, that's obnoxious. Custom file extensions just confuse people because now you think you need a custom jar extractor, right? Hmm. Data.pickle. I don't know, let's put this here. Dummy takes no arguments. I guess it's not finding the class. So it should be giving me a warning. Oh no, the debug is off. Okay. So, module root. And whitelist has... I see. It's kind of weird. Why does it do this? Ugh. I actually don't understand how this is loading this to tinygrad. No, this is saying that it's only allowing you to load stuff that's like has the top level thing defined in torch or collections or whatever. Maybe it does want the state dict, right? No, but it shouldn't. It should want the pickled model. That's weird. But then and I do not understand this thing. I'm trying to think like what the odds are that I can get this whole thing working with the fancy model versus just like really quickly doing an MLP and loading that right now, right? Hmm. I mean, it looks like they just want the state dict anyways. Like, you see that they're constructing like this nested dict of parameters. I don't know how they will convert that though to like. I don't know how they're gonna convert that to a tinygrad net. I mean, I think initially the easiest thing I'm going to be able to do for a quick demo is like, yeah, this is cool, and maybe one of these will work eventually, but I can probably just make an MLP work really quick, right? Isn't there an NumPy C API, literally? There's a NumPy C API I can use to just implement an MLP, right? Well, I think I should just do this for now because, like, otherwise I'm going to be here fucking with more and more frameworks, like, all day, driving myself nuts. Like, this is not the goal, right? I would like to just have a 400 line piece of code that just does it. Do you need the NumPy C API? Does it compile well? I don't know. I probably don't. I can probably just make Claude make me an MLP. So what I was doing before I started this nonsense, right, was oh, that's weird. Why does it open Raylib? It opens the snake thing opens Raylib? What? Something's weird. Where did it get render mode human from? Okay. Okay, yeah, this is gonna work. So this will train me CPU snake with like MLP or whatever. What's the current state of the C snake? We've tried PyTorch, Onyx, and a little bit of tinygrad trying to figure out how to get the stupid models to load. And I haven't been able to, so I'm just training a really simple model, and we're just going to make a C version. Native. I don't need grad because I don't need to train. Pufferance. Yeah, training is the normal RL stack, and the goal here is just to figure out how if like we can run a cool demo on WebAssembly. That's all I want to do. Trying to think how I want to do this. Do I try to do code gen, or do I just try to make... And we just make Claude do it as a starting point, because I don't know what the fuck I'm doing in this space. But I mean, I assume that there's like enough of these online that it should just be able to gen something. You know, the C code gen, would that be easier? There's got to be something for this, right? Like, no, not this. How fast should Atari run in Puffer? Trains at 30,000 steps per second or so on a Puffer box. It is quite fast. I think we just do it custom here. I still don't know if I want to do code gen though, or... It's gotta be like PyTorch C code gen. Guess not. C++. This is what we want, isn't it? I think it does C++. Ah, too much bullshit, man. Let's just try this. trying to think what format I should save the data in. Probably just flat data, right? Yeah, that's like a trivial thing. This is going to be obnoxious, actually, now that I'm thinking about it. There's no good way of manipulating. Are you planning to support GPU accelerated ends with buffer? We already do. We have, in the dev branch, there's integration with GPU drive. I made it 5 times faster than the original in 3 days. You can go play with it there. We're about to do carb sweeps on that as well. I just have to finish this so I can follow up with those guys on it. I'm trying to think what this should even look like. I should just go look at, like... Okay, this kind of got large, didn't it? What happened where... There's no LLM.c file, is there? Oh, man. Oh, yeah, here was the original. Perfect. So float. Star. Should just be a float pointer to the weights as well, right? Yeah. See? Yeah. 1 second. Well, you'll see what I'm trying to do. We're using Sonnet to, like, start a bunch of stuff. I haven't written C in 10 years, but there is going to be... right now, we have the environment in C, we have the rendering in C, and all I need to figure out how to do is get the networks I've trained to actually run... I can get PyTorch to run in C++, but I can't compile that for WebAssembly, so we're just, like, getting Claude to give us a shitty custom thing just so I can get a demo working, and then maybe from there I'll figure out how to, like, either use something or write something to do full code gen for everything. We'll just go back and forth with this thing a couple of times. We'll probably get it. So here's the idea, right? I'll show you what's going on here. I hate having to, like, lean on Claude for any of this crap, man, but... So here we have like 300 some odd lines. Here's the entire Snake environment ported from Python to C. It's got everything that you need. It's almost one-to-one with the original. I really don't like the way that the 1D, like the array logic is indexed like this, so I'll have to think about that, but everything else should be good. And then we have a raylib renderer right here, which is very, very simple, that does the graphics, right? And do I even have this? Yeah, I still have this open. So this version is not correctly scaled, but you can get the idea. This is SnakeEnv. Now, I have this other file here, which it does human input with raylib and sets all the parameters and everything. And I've been trying a bunch of different ways. Like this here is the PyTorch C++ API. This one's actually very, very easy to get working. This is pretty nice. I would accept having a little bit of C++ if I could make this work, but you can't compile PyTorch for WebAssembly as far as I can tell. So that sucks. I tried Onyx. That was also a pain. I tried tinygrad a little bit, and I couldn't quite figure out a reasonable way to do that. So now I'm just doing like a one-off thing for just some very simple nets, just to get this demo running, and then hopefully we'll find a way to, like, get around that afterwards if this thing is substantial. Okay, so what did this thing give us? Okay, yeah, this is trivial as expected. Let's do... Oops. Where are we? Save net flat.py. Nope. Okay. Architecture.txt. Oh, set no paste. Model, was it snake? Snake model, other way around. Model. And then you save this to... Oh no, it just wants the file. Wait, file name plus... Oh, stupid. I don't want this, at least not now. Maybe in the future. To file. File name. Flatsnake.pt. Okay, this is good. Yeah. Quite a bit of beginner in RL. Well, welcome to Pufferlib. This is me doing crazy shit. The normal stuff in Pufferlib is much simpler and easier. So, right here, we have all the Puffer stuff. We've got all sorts of demos. We have all sorts of fast M's that you can play around with very, very simple Python code without a bunch of complicated crap. Let me see if I find the main example file. So, where is it? Clean Puffer is our main demo file. It is somewhat chunky. There are only about 300 lines of actual RL code in here that implement PPO. The rest of it does logging and stuff, so you can tell what's going on, including this nice like little local dashboard and other stuff for that. You got a bunch of envs you can try out here. Should be nice and easy. Alright, so that is what I am doing full time. I am trying to make reinforcement learning sane and easy. Though admittedly, writing stuff in C is not exactly sane or easy. Yeah, of course. This is basically what I'm doing at the moment. This is like a weird day for me. I'm trying to make a really cool demo because it would let me put one of the M's that I built online so people could play it against the AIs, which would probably be like a really good way to show off Puffer. It's the only reason I'm doing this. Otherwise, like, we have way simpler ways of doing stuff. Okay, where's the C code that this thing wrote? More than I wanted it to write, but this is decent enough, I think. Copy this, and we're gonna actually do some stuff with this. So copy claudesnake.c. Okay. Standard lib math. We have this main function up top, so we have to go. It's C, so all this actually needs to go up top. Linear layer, ReLU. Okay, this is what we wanted. This is really simple, right? And then we have load weights. Okay. And we need to now merge these. Which we can do. Let's do this up here. And sample input here, that's going to have to get moved. But we can start with this. Printf. Done. All right, and free hidden. Oh god, this is the worst. That is not a good implementation. Not one bit. But we'll start here. Flat. Gen. Okay. Local, this one is good. And we're gonna GCC this one. And yeah. Flat snake. Flat snake.pt. Our model name. Build local. Forget that I'm writing C. This runs. Build snake game. Well, there's no way that actually works, right? Yeah, this is not the right file, I don't think, because local. Okay, it's in here. .snake game. Error loading. Really? What did I have to do for this again? There was something, right? Shoot. lraylib. Should just need the lib, which I have. May as well GPT while I still have the subscription. Okay. I don't know why this is not in the library path. This one should work, I believe. I had to learn more about how this stuff works. This is what years of writing Python does to you. What? WL comma? That's freaking bizarre. Uh, well, that's new. Well, I guess we'll not. We'll just have to export for now. No such file or directory. That is bizarre. Can I not, like... I actually don't understand how the hell that's possible. Oh, wait, is this an internal error? This could be an internal error, right? I didn't realize I'm stupid. Okay. There, that's what it was. Okay, so I understand what was happening now. It was the no such file or directory was on opening of the file. Duh. Let's make some changes here. And yeah, now we're jamming because this is so nice. Look how fast the build times are with that. We just immediately can build our code. We can run our code. Things are instantaneous. This is the way, you know, code is supposed to be, right? And I'm the red snake there that's like right next to the food. You can see it, right? Now I'm, okay, perfect. So now all we have to do is, do we get done? Yes, done here. I'm actually incredibly surprised that that even runs first try. I'm going to go use the restroom, and then what we're going to do is we're going to get this thing correctly loading and controlling the snakes. And if this all works correctly, I will be incredibly happy because, like, I'm just so sick of, like, big, heavy build systems and things to maintain every time I build a demo. Like, if something like this works and we can just have a C file that, like, you build with GCC in instantly, and we can just stick this online, stick it locally, do whatever we want with it, that's awesome. So I'll be right back. Okay. I saw your thing on Twitter, DT. I don't know if you're still there, but we do have Discord. It's literally discord.gg/puffer. So we're not hard to find. I've had a few people try to buy the URL off of me, but it's ours. Discord.gg/puffer. Paid a pretty penny for that one. Okay, so take these frees, put them down with the other frees. And should be right here. What are you trying to do today? By the way, I started a code to make a faster breakout end with pufferlib. You might want to pick another one because we have another guy in here who is already doing breakout with puffer. Let me find you this. But we are, if you wanted to make fast Atari M's for puffer, we actively, that is one of the things we want contributions of. Like, if you just, like, look at the way we did the Snake Env, or, like, one of the other M's and just make million-step Atari M's, that's exactly what we're looking for at the moment. Unfortunately, there are no bounties on things like this until we actually have revenue, but, you know, we will give you some shout-outs and some stuff for that. Where's this stuff? Okay, so here he forked puffer, and if you check his thing, he's added... Ocean, where's this thing? Does he have breakout? Where is it? I don't know where his thing is. I know I saw his branch. He has a branch somewhere here. Oh, it's probably on dev is why. Yeah, that's why. It's got to be on dev. Yeah, so right here, I'll link you his stuff. So we have somebody else doing Pong. The ones that people haven't done yet, I think that the best ones to do would be like the original DQN 7 environments, which are, let me show you. We have bindings for them. Yeah, I'll show you. So, oops. Let me find a proper term. Oh, cool. This trained us a nice model. So here are the default Atari M's, which are the ones that are used in the original DQN. So you have your pick. Beam Rider, Enduro, Qbert, Sequest, or Space Invaders. Pong and Breakout are already being done. I'm trying to think which of these would be hard versus easy. Probably Space Invaders would be, like, relatively reasonable to do, I think. I haven't played... I really should play some more of these. Let me see. Let's see. Yeah, that's what I'm looking for you. Okay, so this is Sequest apparently. I'm not sure how what the actions are supposed to be here. Oh, for some reason I can't press just the down key. Oh, okay, so don't run into those. What are you supposed to do? Let's see. You die when you go to the surface? Really? Oh, you're supposed to pick up these passengers or something? I don't know if I have the keybind set for this. This one would probably be slightly difficult to do. Yeah, there's stuff shooting projectiles and stuff. So maybe not this one. Let's do... Test. Qbert any good? Okay, so this is the Qbert. What? I'm confused. How are you supposed to play this thing? These games do not make sense to me. I think Space Invaders is the one that's easy, that makes actual sense. This one should be good. Let me see. Is this hard? It's not too bad to do something like this, right? Probably not as easy as like pulling a breakout, but not that bad. Yeah, looks reasonable. You don't have to, so the thing is, you don't have to make the graphical version super fast either. Like, what you're going to end up doing is you're going to end up having like some state-based thing. Did I get hit? Oof. Oh, they get closer is why. Okay. Cool. I mean, it's reasonable enough, right? Probably somewhat harder than Breakout. Not crazy, though. Let me see if I can win a level. Real quick, just to make sure there's not, like, something crazy that I'm forgetting. Like, is there, like, a spaceship or something that, like, comes to kill you? Challenging, though. Ah, they got me. But I have some lives left, maybe? That works. Do I have a life left? Yes, I do. Yep, okay, I died. I got 570. So, yeah, hard game. Is there some application of DDPG method in here? Nope. We just do... So Puffer's not focused on algorithms at the moment because so far, I've been in RL for like 7+ years, and there's been like no algorithmic progress over that time, frankly. Like, so far, just having fast sims and good data and getting the engineering right and like hyperparams and stuff has mattered so much more. So that's what we're focused on with Puffer. And the results speak for themselves. Like, let me show you something. This is something that we have that nobody else has. Where is it? So we have all these sweeps, right? All these hyperparam sweeps. And if I just go find one of them, I did all these GPU drive sweeps that are like clogging up my inventory. Here's BeamRider, for instance. This one work? No, this one didn't work. Everyone else, though. I can pick any other end. Come on. Let's do like this one. This one should be good. This is the Enduro one. So look at this. We just automatically tune all the hyperparams in the environment with carbs, imbues hyperparam algo, and we kind of just solve everything just based on tuning alone. So we get like optimal policy for any amount of wall clock time invested in solving, and we get, over the course of training, we get better and better policies. So yeah, this is stuff we're doing with Puffer these days. Go back to some C. So I think I need to do... Where's the input dim? Ah. (11 times 11, I believe. 28. Output dim is... We'll see. So our default policy here... Oh, okay, this is actually a char. Do you have a Discord or dedicated community? Yep, discord.gg/puffer. Got dedicated support and discussion and all of that. Also, if you have not already, we're almost at 800 stars. Let me see. Yeah, 798 stars. So if anybody wants us to help us hit 800 today, feel free. Helps me out a lot. This is all free and open source. I work on it full time. More than full time, really. Kind of all I do. Okay, discrete of 4. We have 1 second. I gotta take care of one thing. I know what the data shape is though, so we'll fix the nets as soon as I gotta take care of one thing real quick. Okay. Let me just open one thing here. Text. Open. Kind of juggling a million things today. Okay, so we know what this is now, right? So the input dim is going to be 11 by 11, and the hidden dim is 128. Output dim is 4. 799 stars. Awesome. If anybody else is watching and hasn't started, we could hit 800 right now. I'm going to just tweet it so we hit it. So we hit 800 right now. I'm going to beat Will to Slither IO stuff. All right. Hopefully that gets us 800 today. So let me grab from the other thing. Compute. Or compute observations. Might get called. Oh no, it gets env action tensor. Dot forward. Where is this? Step env. Oh, observations to tensor, right? Yes, so it's right here. It's just env observations. So what we have to do is we have to cast. I'm going to write this myself instead of using Claude. So what we're going to do is we're going to allocate this up top. Input dim times not size of float because it's a char. And then what we're going to have to do is float star. Right here we should just fill I less than batch size times input dim. Hmm. $800? Heck yeah. That's awesome. Thank you guys for the support on this. We passed Sample Factory this week. That's crazy. Wow. We're going to keep up the dev. I'm going to keep up the dev. I'm going to see if I can even up the hours a little bit, because really, like, this is starting to take off. We just need to get... I want to get a couple of these demos so we get a... Like, I think once I have a few of these demos online, people will really see what we're doing here. And then everything's just got to get polished up with the sim update. But yeah, I'm not going anywhere. We're gonna fix this field. It's so awesome. Thank you. Best thing I can do is just keep coding here. No, this is the wrong syntax. I'm thinking Python, right? It's float. Right? I think this is it. Patience waits. And output. Dude, this is so stupid how that it did this. Yeah, this gets... Let's put these allocations here. What did we make the signature input? Probably not going to need the print, but we'll use it as a debug for now. Input hidden, output waits. Hidden, output waits. And then here, this does not have to be random. This is actually going to be env actions I equals... I think I need a cast, right? I. Unsigned int. Like this. malloc invalid size. Sample output. Okay, so it got here, and then we got malloc invalid size. So how's that possible, right? Because MLP forward just gets called here. And there's no malloc after this. Invalid size unsorted. Oh, shoot. Yeah. Put... I wish I had, like, some... at least Super Maven or something to autocomplete. I really would like to have the Super Maven just work with these C files. I don't know what's wrong with it. Bothers me. Well, maybe I should just be coding raw C for a couple days anyways. Then output dim plus plus. Join my stream right now. You're doing Slither, right? What's up, Will? We can do a co-stream thing at some point as well. Let me see. What are you up to? I'm sure you've gotten Slither to do something, right? That's funny. I'm in the stream. What are you doing? Okay, OpenAI Gem environment that connects you to real Slither servers. All right, cool. You're gonna get so banned on this. Cloudflare's banning you. You're getting Cloudflare banned for this. Freaking botting Slither. So slow. Yeah. Yeah, you can do this. This is cool. Okay. Will's doing fun stuff as always. We do things rather differently. Uh, okay. All I wanted to do is fix this. I need to make this thing actually sample action. So what we're gonna do is if, was it output I greater than max is a logit, right? Logit. God, I'm so used to Python. Max logit equal output I return action equals I. Okay. And then we just return. I'm so used to Python that I still want to put like the extra spaces even though I have the braces. Is that silly? Like, I don't know. Unsigned int. Return the action. What did I do here? Did I put a parenthesis instead of a brace somewhere? Huh? What did I do? Int I is 0. Expected. Oh, here, up top. Okay, well, this does not freaking work. If I run it for longer. Why did it work the first time I did it? Well, I'm going to just paste this into Claude. At least I wrote it myself, this portion myself. So the getting back used to C again is in progress. I actually really, if I have a couple debug tools for like, a couple debug tools, I'd actually be very, very happy with this. Let me see. And I'm not even using Super Maven or anything there. So this can be substantially less painful. Not this, we want Claude. Check dimensions in code. Might be providing observations with a different size. Observation size. Okay, so it does not really know. It's just saying it's giving me generic debugging advice. Cool. So I actually have to find my own stuff, which is better. It's breaking in the forward pass anyways, we know, right? Oh, isn't it just the print statement? Output dim. No, wait, this is valid. I hate not having like multi-dimensional arrays. Is there a reason to do everything flat versus in multi-dimensional arrays? Flat array is contiguous. When using flat arrays, you do a manual index. Interesting. How does this do it? It's always flat with here. I do not like the flat indexing for everything. That's the one big complaint. I mean, we have access to the exact same thing as I would want normally, don't we? Yeah, we could just make this a two-dimensional array if we wanted to. I have to do some looking into like whether that's actually a bad idea or not. We'll leave it this way for now. So let's do, what is this? Float out. I forget you can do it in loops like this. Put I times dim plus I. That a thing? No, wait. Yeah, this is it, right? This is the indexing. Oh, well, this is wrong. It's supposed to be 16, right? Don't need this. Okay. So this is now running, but crazy things are happening. So let's comment out these prints. Oh, I just remembered a thing. It's okay, I'll do it in a second. And where's FPS for this? Raylib client. Well, maybe this just works. Okay, so this is way too fast. I don't know why it's this fast. Something's weird, right? I think something's definitely weird. Ah, well this is not going to work, right? Yeah, this action is totally screwed up. Don't start output. Float star. So what we'll do is well, what is this loop that I just wrote? This doesn't make any freaking sense. Yeesh. I really miss having vector ops. I'll have to think about that. Just do it like this. Batch size. It's I times output dim plus J. J. How's the breakout game going? That is Noah is doing breakout. This is the snake thing that I'm working on here. Say 92. I always forget these. Unsigned int star. Something's still weird. So first of all this should go. All this should go above here so you can still play it. Okay, let's see. So I see where I am on the board. I'm this red dot that's going towards the blue one right now. It's like spamming all these little snakes all over though. Which is weird because like some of them look like they're behaving reasonably. Like a few of them. Can Clang check for... Clang fsanitize -g. Clang is kind of chunky. Oh, because it installs all the C++ stuff, but you can use it with C. That's fine. It's fine. So look at this. This is exactly what I wanted. This shows me that I'm going out of bounds. So that is what is wrong. And it shows me exactly where as well. Batch size times input dim. This is a char star. Width, height. What, 2 times vision plus 1, 2 times vision plus 1, times num snakes. What is being passed for vision? Vision is being passed as 2. This is wrong. This should be 5. This is still being passed wrong, which is very weird. Size is 1936. 1936 bytes. This looks totally fine to me. Oops, that would have been bad. I actually want to add this. Okay. 11 times 11 here. Batch size is num snakes. Observations. Batch size times input dim, right? Float env observations of I. Okay. Print I. Percent D. Like this instead. Oof. Okay, there it is. So 282. That's weird, right? How's it out of bounds here already? Oh, is this two-dimensional? No. It allocates here a char star. Num snakes times 2 times vision plus 1, 2 times vision. Where's vision come in? It's in the init, right? Unless it's not being passed correctly. Allocating vision. Vision is 5 total bytes. This is good. Breakout's going well. Env while training runs at 300k. Nice. Working on some smaller features that were in the original breakout game. Perfect. Great work. It's exactly what we want. This says that I'm allocating 19396 bytes, but I am out of memory. I'm out of bounds at 2. How's that possible? env.observations. What's batch size? Batch size is num snakes. 16. See about this one. Let's see, is it It's failing on 148, which is... Oh, it's actually failing on the assignment. That's even weirder. Wait. Time size of float. Sad. Me stupid. Me so stupid. Man. Gotta learn my C. It's still spamming a bunch of snakes all over the place. So we'll have to figure out what the heck is going on there. We have a lot of snakes that are behaving reasonably, though. $32 food. A few of these are like... Well, let's figure out why all of these like are flashing all over. Really not seeing anything. You know what? One thing I want to do is I want to take a screenshot and count the actual number of snakes on any one frame. How many snakes are there? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. So there are 16 snakes. They do appear to be dying randomly in ways that should not happen. What if I give them a random action instead? Okay, if I give them a random action, this does not happen. So my guess is that I'm out of boundsing the... I'm like out of boundsing the action somehow. Unsigned int action is 0. Output dim. And then actions of I is equal to action. Print %d action. Eh? Oh. I understand. I just forgot to update a thing. Boom. Okay, so these are not doing anything at the moment. They're not doing anything yet. Let's see if we go get the actual policy that we do want to be loading, because I think we're loading bad weights at the moment. Want B. So this is the model that we trained. As we can see, this is actually a very reasonable looking model. This trains very quickly. This is less than 5 minutes of training with very basic policy. It trains stupidly fast, nearly, this is 750,000 steps per second with like whatever random settings I happen to have. And then if I grab this model from here, and what we're going to do is, oops, no, we're going to curl this model. Yeah. Where's the script that we added? I forgot what we named it. Save net flat. And let's just print. Okay, we're gonna have to do a little bit of messing with this. So are these not transposed? We're gonna need to make some updates in order to make this work, because there's also a value net that we have to ignore. I'll be right back and use the restroom, and then we'll finish figuring out how to get this net loaded. And as soon as we have the weights loaded correctly, we will have this thing like standalone runnable on anything, which will be awesome. So I'll be right back. Okay. So let us take a look at what this network looks like and if it's correct. So it looks like it is a 4. The tensors are like transposed or something, right? Let me just put this back into Claude real quick, because I don't know how the shapes... Okay. Some C for work code. Can I not paste reasonably? There we go. Okay, we'll see about that. And in the meantime... Okay, so let's copy this because... Get rid of this. Oops. First layer, second layer. Max over outputs, this is fine. And then this is just the transpose. So I noticed that was jank. This already had a bias in it, which is good. Good. And then what we should be able to do is for lib environment C snake. Okay. Build. Where is it? Oh, what happened here? I was... Something is happening differently here, right? Still doesn't look right. So we have some options here. We should be able to do Python snake mode eval model path. Oops, let me make this covered by camera. Snake MLP render mode raylib. It's render dash mode raylib. Okay. Isn't that nice? This is what we are supposed to be able to get. And we can see that we have very reasonable models. Look how smooth that is with the MLP as well, because the model is so tiny. So this is what we are aiming for. So we know the model is good. It just means we're loading or using it wrong. So let me see about that. Check the MLP forward. It does. No, it's not working. Okay, so I'm trying to think the best way to debug this. We had the tensor shapes, right? Input dim should be 121. Let me see what it even gave me here. Yes. First layer weights. Torch.size. Did it do it right? Let me see. 128, 121. Yeah. First layer bias, second layer weights. Linear layer weights are stored in transpose format. Yes, that's what we thought, right? Linear layer. Input. Wait, input. Weights. See, linear weights bias. Okay, so weights plus input dim times hidden size. And this is a float offset, not a byte offset, so this is correct. And then bias output, float star output. Hidden. Batch size. Input dim, hidden dim. Let me go deal with one thing real quick. Okay. Man. We're very close to having this thing working. Maybe, okay, we give the hidden size, the hidden tensor. Let me see where we allocated. Hidden dim, output dim, input dim, right? And second layer, okay. The input is now hidden, right? And weights plus input dim. So yeah, this is skipping the first layer and the first layer bias. Weights plus, and then this is now the bias, which is getting ridiculous. These offsets. Should really compute these better. So input dim plus hidden dim times output dim. Is this correct? Should be. Output batch size. And then what's this action selection do? I times output dim. Wait, what? Well, this is wrong. Oh, they do from J. Okay, this is clever. Fine. Jeez. I think I'm gonna have to just like figure out how these things are stored, right? We're gonna have to actually get pretty. Okay, so let's see the format. Okay, so we have terse. Okay, so this is our tensor, right? And we can see here that we're doing the first row The 128 by 121, right? So if I do weight to 121, it should be 0472. Yes. So this is now storing. Let me think about this. They're doing it this way because they do weight matrix. They are doing like WX plus bias, right? Because the input dim is 121. So let me see the code. Does this look right then? Batch size. Output dim. Input dim. And it's going to be output dim. I hate when they do. You need to perceptually group stuff. You can't just spaces between everything is really gross. Bias times input dim plus I times output dim. I don't know if this is correct. This is hard to tell. This should just be a matmul. If I can just figure this portion out, right? Input of B times input dim. Yes, because the column is okay. Plus I. Yes. Times weights I times output dim. Wait, B times input dim. And then we have I times output dim. I think that this looks right to me. This looks right to me, it does. Well, first, we should make sure that we're actually matching the model, right? Is there no relu? Hold on. Oh, I don't think there's even a relu. Yeah, the default model is really basic. That would be funny if that's like that was the issue. No. It's doing something different, but not good. It's weird because it's like... Let me see. Encode, decode. I'm trying to think how we can figure this freaking thing out. We could technically multiply the two matrices together. All right. Is this really? I'm surprised that this network is so good. Value head. The weights are different from before, aren't they? Or am I just making that up? No, I'm making that up. Yeah. Okay, so it's... Okay, so it doesn't need the transpose. Cool. Corrected linear layer. The row major, column major shenanigans. Okay. Nice. Why does this change? Oh, I guess this changes because this is also assuming, okay, we'll just remember we have to comment the relu. This. Still not working. Input dim should be 121. We should be able to maybe, let's like open the file and see if we're reading stuff correctly. Yeah, so they're the weights. That's what we expect, right? I think I just have to... We could also not be reading the OBS data in. I would think that this would work. Let's see the observation data. Zero, 1, 2, 3. Okay. 121 divided by... It should be 49 or something? No. It should be like 60, I think. Yeah, so 60 and then 59 be 0. Okay, so we are seeing the data in here the way I would expect it to be. Data is in here the way I would expect it to be. Then input. One 128 by 121. So the first output then needs to be 121. It's output dim, isn't it? I think this is output dim. It's not because we read out of bounds, it seems. Is there anything else I'm missing that it would be, or is it just going to be this implementation being wrong? I mean, we're not going out of bounds anywhere. I know that at least. Plus equals, no. Sum is set to 0 correctly. It should be output dim. Well, why is this out of bounds? I'm running this with Clang, and this gives us overflow if I do that. So I have the dimension that I got right here. It's 128 by 121. So it's the hidden dimension, comma, input dim. So the first 121 floats are going to be the first row. And then the input Jeez. I'm like, I'm not even positive this is where the error is. I don't know where else it would be, though. I confirmed that we're not using a ReLU, so it's literally just a linear net. So it should just be linear layer, linear layer. I mean, unless this is screwed up, let me see. Input dim times hidden dim. Yeah, that's the size of the weight tensor. It's the input dim, right, times the hidden dim. So that's where the bias is going to be. Input dim times hidden dim plus hidden dim. Yeah. And then this is weights plus input dim times hidden dim plus hidden dim output dim. It's bizarre. I'm trying to think if there's anything else this could be. I should double check the weight D type is it should be float 32. I mean, it's got to be the weight D type is float 32, right? Yeah, float 32. I mean, we checked that the weights are what we expect. So, because I can do GDB and I can do, let's see, linear layer. So I can do break on line 12. Okay. Oops. And I have input 0 is 3. I have weights 0 is, yep, that's what we expect it to be. Oh, B, yeah, so these are zeros. If input is m by n, that's not how Torch, wait, I don't think that's how Torch does it though. I think it does, Torch, it looks like to me, Torch does AX plus B, like WX plus B, not XW plus B. So it should be... What's the dimension of that? Yeah, it should be, weight should be P by N, no. I mean, we can go try to write this out. I don't know. Let's not do it online. Let's just do it here. So we have like B, the weight should be batch size times input, right? And then we have multiply this, and it's input. Oh wait, it's batch input and batch times input, isn't it? Wait. No, the weights are not batch size. The weights are hidden by input. Oh, maybe the inputs need to be transposed because the input should be batch times input. Maybe that's the issue. Usually I write it as WTX. Yeah, but the thing is they already have it in the format, so that it's just WX. I think, right? Why does it look like the input needs to be transposed? Well, because it does. That's why. Does this tell me something? Hold on. Yeah. I'm just getting confused here. Batch times input plus I. Is that not right? I mean, what we could do as well is here. Another thing we should probably do is like, can I just print out plus I. Oh, not plus I. Input dim. Input dim. Input. Or I don't need to add anything because that will just give me. Like, what dimensions are we looking at here? Holy hell. GDB. So break on line 15. Run. Okay. Oh, we have to do... You have to do /n. I forgot to clear it. Why am I not seeing the prints? It's just /n, right? Fuck. Why am I not seeing prints? Is this Windows? It's WSL, no. If I try running code on native Windows, please just shoot me. Maybe I didn't. Let me see. Oh, yep. Dope. Dope. Okay. Is this what we want? This is not what we want, is it? Isn't this output dim? No, wait. Yeah. That's not it? Huh? Oh, wait, because B... I'm confused. Wait. What happens if I just... No, this doesn't work. Dude, I hate... This is like the exact type of thing I just fucking can't think about, is like this level of... Like, I understand systems, not symbols. I guess I just have to keep debugging it like this. Let me just look up. Is this it? Did I just have the fucking indexing wrong? Let me see, what did it change? So it did O times input dim. Okay, that looks potentially... Wait. Man, this is still not... Am I gonna have to like write a matmul test? Seriously? I times output plus O. B times input plus I. I'm just gonna give it the whole fucking code, I don't care. This is why I didn't want to have to do this. Because it's just like pasting slop back and forth. It is so stupid. Size. I don't know what's wrong with this. Fuck. I mean, I guess I literally have to write a... I have to write like a test, right? I don't even know how I do that with this. I mean, I really should, right? There's like nothing else I can do. This has got to be something like putting the data in wrong, maybe then. Can I tell from the behaviors? Wiggly behavior. They don't look like they're fully random. Would the obs be transposed? Would that even make sense? Iron range batch size. Freaking writing Python here. It's Like, the reason I'm even thinking about this is because, like, they're doing this wobbly thing. They're doing, like, this wobbly thing, which is... What am I doing? Int I... Man, the Python runs deep. Equals 0. K less than 11. I'm not used to typing these frickin' symbols, even. Okay, now they just, like, frickin' go left or right, straight. Which is weird. Which one is... I'm not controlling any of them, am I? I should be able to be controlling one of these. What the hell's wrong? Oh, this is weird. Yeah, so now I'm actually controlling it. No, so this doesn't work. Okay. What if I just, like... Is there something that's just wrong with the observations here, right? I'm trying to figure out. Does it respond to anything? That's so weird. I mean, am I sure that this is the right policy in the first place? Hang on. I want to just make absolutely sure. Snake MLP, flat snake. Should give me invalid path, right? Yep. These snakes are good. Right. No, this is exactly the same. I'm just like not seeing what I can even do here. This is just god awful to debug. Could there be a difference in the way the game is implemented? No, because I loaded the PyTorch net before and it worked, right? Exact same thing. It's got to be somewhere in this MLP. Context, please. I have a trained PyTorch model that I've dumped all the weights out of, and I'm trying to just, like, it's a really simple model. It's just like an MLP. And I have C code for it, and I'm trying to get it to replicate the behavior in this environment so that I can just compile this whole thing into WebAssembly and put it online. And it's very annoying because, like, how the heck do you debug something like this, right? I guess I really do just have to make a test case, though. Like, there's no other way, even though it's going to be a pain. I don't know, int test LP void signature. So float input malloc. Now we need to get the input size. Right here, we can do observations like this. And then we will simply do for int I equals 0, I less than input dim plus observations. We just make a little test pattern here, right? And then we do, we call the MLP forward, right? Observations, hidden, output, size, input, dim. Okay. Then what is this? Batch size. Sum plus equal actions I printf act sum d slash n sum. Okay, that's a little test for this, right? And I just have to call it, right? We call it here. All the same signature minus observations, because those are, we actually can put this up here, right? What did I do? Expected 9 args, hidden output obs hidden output actions weights. Forgot an arg. Fine. Okay, action sum is 4. And now we can make a Python side test for this. So which is test model. 2. Oh wait, I did. What test data did I use here? Yeah. Do you have this on GitHub? Yeah, all my stuff is on GitHub. This is like a port of the snake env that was already in Python. We're just trying to get it on web. So if you're looking for my stuff, it's all in Puffer AI, Pufferlib. We just hit 800 here, which is awesome. All open source here. Most of it, the new stuff is in the dev branch. Start on the way, and if you wouldn't mind, helps me out a ton. This is all full-time dev on fixing reinforcement learning. So at the moment, this is just a fun demo. I'm hoping that I can solve this relatively soon, but this has proven harder than expected. Okay. And going to your GitHub in the meanwhile. Yeah, thank you. This is a new thing. Most of my work, I do have some lower level stuff, but like it's in Python. It's pretty one-to-one with the C, but I haven't written in C proper in like 10 years. So what we're trying to do here is if I can just make like a 400 line file that has the whole environment implementation, the renderer, and the neural net forward pass, I can compile the whole thing to WebAssembly and just put it on web, and then you can have like play Snake online versus 1,000 reinforcement learned AI opponents, right? We're literally like one bug fix away from that existing. Got long and float. Okay. But we know it's encoder, decoder, value head. So policy dot Okay, so now we have something at least. Let's do view 16. Okay, so now we have something to go off of at least. Let me go use the restroom real quick again, and then we're going to see whether I just have the test wrong or whether the test is actually useful and whether there is a discrepancy between the implementation of these two models. That's what we're going to just have to hammer on until we get this right. The good news is it will be pretty darn easy. We'll at least be able to do arbitrary MLPs trivially when this is done. Obviously, we'll have the whole nightmare of like LSTM and conv and all that stuff afterwards if we want to do full models without using a framework. But yeah, this will at least get us somewhere. So I'll be right back. All right. So let's see. We're going to modify this a little bit here. Okay, so now we have all these layer sums, right? Perfect. And now we're going to do the exact same thing here, because the way that we have this constructed, we should be able to do this, right? So I really would like Super Maven to be working with this thing, because like the unfamiliar syntax is so clunky for me to be typing. I don't know why it isn't. But fine. In the meantime, um 0 for equals 0, I less than size times input dim plus whatever. We'll get used to the syntax by typing it right here. Observation sum plus equals observations I assigned hidden sum 0 hidden, was it hidden dim? Batch size times hidden dim. plus observation sum plus equal. Oh. Hidden sum plus equal hidden by sum 0. Batch size times output dim. Okay, we just treat them as flat buffers and sum them like this, right? And then we do print observation. Whoops. D observation sum printf, and I missed a semicolon up there. Whoops, semicolon. Hidden sum and D hidden sum printf. And I already had that one. I also forgot all the slash ends on these. N. Okay. Nice. So, why did we do all this? Well, we can see here that the observation sum matches here. The hidden sum does not match. It's very close, but it doesn't match. And the output sum does not match either. So it does appear to me that we have an incorrect implementation somehow. Oh, but wait, hold on. Microsoft. I gotta just delete Windows at some point. I don't know why it does like all these freaking things, like hide my whole desktop on me. Thank you very much. It's exactly what I wanted. Okay, where did all my stuff go? Oops. Today is our NERPS rebuttal deadline for a thing. Okay. Where'd all my stuff go? Right here? Okay, so this should be float. This one is unsigned int. The rest of them are float. Let's see if that fixes it. Format specifies... Oh, is it %F? Okay. Now, what do we get? 6, 6. Okay, it's close. but not there yet. So let's figure out why. So the data going in should be the same. Oh, let's do some of weights just to be sure. Let's just do weight sum. Int I equals 0. I less than, this one's hard. It should be equal to input dim times hidden dim plus hidden dim plus hidden dim times output dim plus output dim, which is weight matrix bias, weight matrix bias. Okay, weight sum. Okay, weight sum, negative 475. Let's see if we do our own weight sum. Four seven five 2191. Is that a significant difference? Wait. 219? That's a pretty substantial difference. Shouldn't it be identical? If they're both float 32? Let me see something. Man, is that worth tracking down? I'm trying to think what would cause that difference. Weight encode. Is there anything reasonable that would cause a difference of that magnitude? It's like small, but maybe substantial. Okay, so this is 432, 2837. 2853. It's a tiny difference. I don't know if it's gonna matter. Let's look for the rest of the stuff first. And we'll see if it makes a difference. So observation sum is the same, which is good. And then there is the hidden sum is quite substantially different, right? 663, 668. And then the output is completely different. Okay. Didn't mean to do that. Okay, so here's the hidden. And what we're going to do is if I less than 10, printf hidden %d, %f, I, hidden I, right? $86, what'd I do? Oh, I forgot it. Okay, so hidden. We see that these are completely off. $22. Completely off. And if I put a breakpoint here, I should be able to see coder. Wait. Okay. And let's do Now let's set a breakpoint here, I think. GDB. Oops. So we do break 10. No, I went too far. 12. 1. Okay, so we take input. We have B, I, right? And then we have input 0, 0. Oops. I can't do comma. Weights 0. Okay, so input 0 is 0. So this gives us the correct first component, right? Which is 0. Then we do continue. And then we take is 1. Output, which is 128. Yes. I think that's correct. So what we do then is we do input is 0 or input a 1, and then we take go away Adobe. God, who even came up with that idea of freaking pop-ups? This does not look like the correct weight. It should be this one here. And then oh wait. Okay, input is correct. And then what about the weights? This one is good. This one is not. It should be weights of 1 here. How does this make sense? (16 by 121), right? So batch times input dim. Let's group these so I can read. So batch times input dim plus I. Yes, because you go over the input repeatedly, right? And then you multiply Ah, shit. I closed the wrong window. What happens if I do this? Out of memory? God damn it. Well, this is actually these two weights here. Where is it? No. Okay. Here we go with this. This is the most freaking debugging I've had to do in a long time. But we have to like trace through exactly each of these matrix calcs. Freaking line by line of C. Okay, we have the breakpoint. Sum is 0. Weights of 0, 3, 3, 9. Yeah, this is the same weight. And now, put dim plus I is... Oops, we got to do continue. Okay, this is 1. Dim plus I. Is 1, so weights of 1 here. 4, 5, so this is good. This is actually correct, it looks like. So break 14. Clear 112. Now we're at 14. And we get the sum. Then this is what we want here because this gives us the first weights. Sum. Wait, model. X of 0. And this matches perfectly. So for the first output, this matches perfectly. And then what we do is this is going to be the second output. And we hit continue. And now it's wrong again. B is 0. O is 1, right? Output dim is 128. I think this is input dim, not output dim. We're going to see if I'm right. Freaking. Okay, that's the first correct value, right? That is the second correct value. So now what we need to do is print O. Let's print the sum here. The sum does not match. Oh, wait. How's that work, though? Because the output dim is 128, right? So this is fine. 6. Oh, okay. Now we have O. Now we're on the second example. And it matches. Okay, so the policy is not helping us here. Let's see what our outputs were from before. We have the sums up here somewhere. Hidden sum. 6, 8, 4, 3, 6, 1, 3, 6, 4. It's almost identical. There's a little bit of drift that we're going to have to find, but it's almost identical. You see the hidden? The output sum. The output sum is also correct. And the action sum is now correct as well. So now these functions should match. But when I look at snakes, it looks to me like the output is backwards, right? Look at this. See, it's going backwards. Look, you see how it goes away from the... Interesting. Let's take a look. So the test case is now fine. Let's try this flip again. Let's try this flip. Nope. Now this just randomizes it, right? Yeah, so this is them just running into walls, as far as I can tell, which is not the expected behavior at all, right? So we were on the right track before, I think. Jeez, at least we got these to match so far, which is the main thing. Oh, that took some debugging. Claude was wrong, by the way. Claude was wrong. Okay, here's what I'm going to do right now. I just had somebody ask me to review rebuttals, a draft of rebuttals for NeurIPS. So I'm going to go grab a quick shake because I haven't eaten. I'm going to take a quick look through those rebuttals. And then I think we're very, very close to having this working. So the goal will be to finish this today so that we can get on to all the other stuff we've got to do. But I want this shipped today. All right, I'll be back. Oh, man. Gotta take a quick pass on this rebuttal on my side monitor real quick. Not public. I gotta check the deadline on these actually. Just today. Okay. Let me just read a thing real quick then, and I'll be able to keep going. But I'm gonna have to end early so I can finish something with this today. Let me put a reply. Okay, cool. Back to this for a little bit. At least I want to get this working and check a couple other things before I have to go do rebuttals, more substantially. So, let me see how I feel. Let me check a few things here. So, let me see where they do compute. Oops, I just saw it. Okay, let's get back into this. So, right here, plus R plus C, right? Does this get called for us in compute observations? It does, right? It gets called at the end of step for us. It looks like something is flipped. It really looks like the data is just flipped, right? Is there a way that that would happen? Really shouldn't be. We know that it matches. How did I load this data? Observations to tensor. Hmm. We know that the MLP matches. The action selection matches. Do we want to try messing with the data a little bit just to make sure? Divide by, I don't even know. What do we divide by? 1,000? By float. Okay. We need to run the test. Okay, action sum is now 20. Action sum is 20. So we have the same. Yeah. We have things matching now. Oh, that's what I'm missing. What am I missing here? If the PyTorch network that I loaded works correctly, so that means that the observation should be being computed correctly, right? This thing here matches the PyTorch implementation. Let me look for anything stupid. It's possible we have something stupid in here. Actions of I equals action. Hold on. Max logit. I times output dim. Is this action? Well, wait, the action selection, I shouldn't even be questioning the action selection because the actions output are the same. Right? Let me double check something. That was weird. I'm trying to think like what even the error surface is here. If everything matches, we do MLP forward. We load observations here, right? Step env. Batch times input dim. Observations of I. Why would this one not match? I don't see anywhere else where I could have an error, but in the loading of the input data. But compared to this is the C++ version with the Torch API, which I can't use because it doesn't compile to WASM at the moment. I'd love to just use this and be done. This version here, I times 121. Technically, the memory layout could be like different or something, right? But it like even if it were transposed, right, that still wouldn't account for the difference I'm currently seeing. And like if it were transposed, I wouldn't be getting the same output. Right? These tests should catch that, I would think. Cuz I'm loading the data in the same way. Yeah, I'm loading the data in the same way. That is bizarre. And like it's not like it's kind of weird how these guys work as well. Like look, if I put it right next to is it following me? What the heck? If I put it like next to a food, if I put it in the open, it will like just go in one direction, which is fine. But then if I put it next to a food, it won't go directly next to the food. Kind of weird, right? It looks like it has the board flipped or something in its head. On the network, I mean. And see there, it fell on itself. Like it's definitely making its decisions based on the data, but they're like backwards or something weird. Is the action map the same? It would have to be, right? The action map would have to be the same for the C++ model to have worked. Maybe the C++ model didn't work perfectly, though. I don't even know if that's worth checking. Be the bias. I didn't test the bias. Bias of output. That's how it works though, isn't it? And well, the actions are the same, so it doesn't matter. It definitely is correct, okay? So if I'm assuming this is correct, I'm assuming the whole computation of actions is correct, right? The thing is that really doesn't leave much space for stuff to be wrong, and it still is. Cell size, 10. Doesn't matter. Observations of I. Actions is correctly an unsigned int star. Man, this is literally one bug away. There's nothing else. There's got to be something else it could be. Unless I'm just been staring at this and I'm not seeing the issue here. Like a transpose wouldn't account for this, would it? Let me just for the sake of it, like we'll just oops. Let's just JK. We'll do I K J. No. So this thing, if you like transpose the obs, it completely just breaks. It like just ignores. So that totally messes up the policy. It's not something with the way the actions are getting sent, right? Like this, or whatever. Or is it? Hold on. Keep hearing something. Just an issue with one of the windows. No big deal. Window, like, I don't know, it's windy. We're good. So, the only other thing I can basically think of is that like the action map is wrong and I have to do something ridiculous like this. But this doesn't make sense at all, right? It's funny that that actually like does something though. Is there like an action map that I have wrong here? Hold on, maybe it is worth checking this. So, up, down, left, right. No, these are all reasonable as well. I mean, it makes sense that it would be. Is there some other part of the network that I'm forgetting about? Because this matches the reference. Like, the default model should not be that complicated, right? It's just encode and decode. View, batch size, -1. Oh, there is a relo. Ah, there is a relo. I missed it. I missed the frickin' relo. And I didn't catch it. Wait, how did I catch it? Wait, is that actually a thing? Wait, did I... Oh, because I tested it without the relo. Ah, okay. Okay, we found it. We found it, guys. We found it. Fuck. We found it. God. Ladies and gentlemen, I present Pure C Snake. Reinforcement learned policies. Environment is in C. Rendering is in C. Directly supports WebAssembly as well. We've got it. Isn't that something? You know, the funny thing about this is it's not just one game. We can very easily say we do cell size 5. Let's do 64 snakes. I don't even know how fast our implementation is. Like, can we make this thing? Can we make this bigger? That's pretty cool. Whew. Man. Well, it is 3:41. We're definitely, there's going to be a little bit more in this at some point. I might even just do this tomorrow all day because this is sweet. We'll see. I'm trying to think what I want to do right now. I mean, okay, so we should probably figure out a few things with this, right? Debugging that just like wiped me out though. Holy hell. There was so much that we had to do to find all that stuff. That's the deepest I've had to go on debugging in a long time. I mean, operation by operation in 2 different languages, matrix multiplication, ugh. Okay. So, I guess it depends on how we want to present this. I almost want to like change gears and do something else for a bit. Like, holy hell. Let me just talk through real quick some of the stuff that has to be done in the relatively near future, right? We need more hyperparam sweeps on the Atari M's. We need like all those baselines to be nice and solid. They're pretty good now, but they need a little bit more work. We have all sorts of stuff to do on the MOBA that we've had on the back burner for like a week because 50K and then this. And then there's some stuff for GPU drive. I think realistically, the easiest thing for me to do right now, just for a little bit, would be to figure out how to fix the thing with GPU drive. Potentially. I really should do that. Let me see if I can. Oops. Well, but I have people here watching for C. So I'm assuming that yeah, people want to do some C stuff. Is that a new message? Do you know what the best universities labs for reinforcement learning are? I don't know if this is just now or if I missed this from before. There's not all that much going on for RL, frankly, at the moment. It's like a lot of robotics at the moment. Not too many places are doing like games plus RL. It's kind of all over the place, really. I guess for games, like there's a bunch of game stuff and RL stuff at NYU, but Like, more so, there's been lots of language model stuff lately. It'll be back, though, and here's why RL is gonna be back. Language model research is freaking expensive, and it's getting to be, and it's already way outside the budget of academic labs. As soon as reinforcement learning is, like, sane, you're gonna have tons and tons of labs wanting to do cool reinforcement learning stuff. And Puffer is gonna make that happen, and it's gonna make it happen very soon. Okay, let's actually just keep going on the C stuff for a bit. Yeah, I'm so sick of LLMs everywhere. I mean, look, you can take 75% of the resources for LLMs, right? Like, yeah, they're good. Like, I just wish that it weren't 99%, because there's a pretty darn good chance LLMs don't just solve everything, actually, and RL's probably the most promising second candidate here. And simulation in general is definitely a very promising candidate. Okay. So I probably should implement a couple different render things with this, and I should do a little bit of figuring about how I want to present the environment here for everything. Yeah. It's just rough because I like just burnt so much with that debugging. I just pushed the C code. It's not cleaned up yet, but if you want to get the C code for this thing, obviously I'm going to be putting it on the Puffer website. But it's in the dev branch of Pufferlib. Start on your way, and helps me out a whole ton. Yeah. Okay. I think then we should make a slightly better client for this thing. I'm assuming this can't run full scale, right? I actually haven't tested it. Can I just do what are one of the configurations that I have? So the 720p one with 1024 snakes is pretty good, I would say. Let's see if we can make that one run. So this is 1280, 720. Max snake length. I don't know, 500,000. 1024 snakes. Cell size should be 1. It's moving very slowly. Yeah, very, very slowly. So, assumedly, our implementation would need to be substantially faster in order to render like the full scale thing, or to do the full scale thing. Let me just make sure it's not the rendering. I wouldn't think it would be, but like... Oh, actually, that's substantially faster. So it kind of is the rendering, huh? This actually runs. So I guess if we just find, if we just do the other arraylib render representation, we should be good. Here, this is cool to watch. Running real time on one CPU core. I think this is about 500 lines now, maybe 550 lines of C. So we can cut this down a bit. Let's downscale the demo a bit, and then we'll figure out what we want to do with it from here. A couple different client modes, maybe. Oh yeah, that's with all the tests and stuff as well. Okay. I actually don't know if I've got more C in me today. And I do have this GPU drive M, which is also really cool, that needs some fixing. Let me just go look and see if I have like a concrete message on what to do there. I'll check the Slack for that to see if somebody's told me. Oops, wrong tab. Oh, hold on. Okay, I didn't miss this thread. This is just from today. Okay, I do have some messages to look at here. Hold on. And then what we're going to do is we're going to probably do some GPU drive stuff, which is a GPU driving simulator that we have support for in Puffer. I just have to read this thread. Uh, okay. I think we're ready to go here. So the bug that, wait, the heck? Let me see. There's somewhere they posted the solution to this bug. I gotta update stuff. I'm just looking at the side monitor for a second to find where there's some Slack stuff. The heck, where'd it go? Oh, I found it. Okay, so let me see if this works. I have some instructions back, and we can show some of this, just not the Slack messages. Where did Restream go? Right there. Okay, so oh, I missed some messages. Recently saw your video of defending your thesis. Amazing work, amazing library. Thank you very much. Any resources for getting into machine learning? I think that there are a few of them in the Puffer Discord or maybe the Neural MMO Discord. Um, it's a lot of engineering for the most part. Like the math side is not that bad. OpenAI spinning up is more math than you need. Realistically, you read the DQN paper, you read the PPO paper, you read a few other papers around. I suggest a lot of the large scale industry ones. I suggest like the Dota paper, the Alpha Star paper, like emergent tool use capture the flag, maybe like 10 reasonable papers, and then you already have a good sort of start on stuff. And you just pick up like CleanRL and start playing with stuff. You will learn things quite quickly if you're using something like CleanRL or Puffer, where you actually get into the code and stuff isn't just automated. Because whenever stuff's automated in RL, it breaks. Okay. This is GPU drive, right? Oops. See if this works. Yeah, okay, this is what we have. So this is a GPU accelerated driving sim that Puffer makes very, very fast. And I was told that it needs to be compiled with the same version that Python is running from, which is kind of weird. So let me see if this actually works. Drive. So CMake. Thank you. Yeah, no worries. I keep missing messages because I got my chat covered. Okay, there we go. Now I can see it. I've got like a million windows and a million things today. 3.10. Okay. Okay, does that do it? Let me see if this does it. Yeah, that compiled a new version. Let's do 2 million time steps. Still seg faults. That's unfortunate. Is it compiling it with the wrong version? No, it can't be. What the hell? window. That's okay. I'll do that. I'll deal with that later. I don't know what the heck is up today. California's usually nice. We've got like crazy winds. That's unfortunate. I thought that we would have a fix for this by now. Okay, unfortunately, I can't do anything with this for now if it's going to be segfaulting. I will check back when they reply to this because it's pretty much like everything is done. It's just that in order to automate all the experiments, the environment can't be crashing every time you run it. So, yeah, unfortunately, we're stuck on that for now. That's okay, though. Do we have any sweeps to look at? I mean, maybe I'm good to go back to the C stuff for now. Let me think. Yeah, there's a lot of stuff to do around here. I just got to pick something and do it. Realistically, we could probably just start some of the Atari stuff at the moment. It's not that hard, and it needs to get done, and it's pretty fun. Yeah. Let's do that for a bit. Yeah. So you just grab Atari depths real quick. Let me make sure I have the updated version on this, and I'll show you what we're gonna do. Okay, so we have all the Atari files. Good. Um, does this train? Apparently it does, which is weird because my baselines don't seem like they ran. Let's go look at this. Yeah, so some of these didn't run, which is very weird. Like C-Quest, I thought would have run. Pong Breakout. I actually don't see C-Quest here. In space, so maybe it just crashed on Space Invaders or something. Cubert's there, Space Invaders is there. Okay, so I guess all we have to do then is we just have to run the Space Invaders baseline, and then we can put together a little report with these, or decide what to run from here. So that's super easy. We can I'll show off launching and configuring these experiments, and then I'm gonna go grab my window that I think, or my window screen that has been freaking blown out of my window by whatever the heck is going on outside. MC Quest mode train, back multiprocessing baseline. That should be done in, whoops. Do not have permission. Interesting. Interesting. Hmm. That's what happened. I think Kyung grabbed my box while I was in the middle of running experiments. Silly. I'll tell him to get a different box. I technically did tell him to grab any box he wanted, but I assumed he wouldn't grab one of the two that I use. Let me get my API key. That was cheeky. Where'd the window I was doing? Okay. Okay, so it is this easy. This is now running C-Quest with a 4 million parameter model, which is just DQN, no, not DQN, nature CNN plus an LSTM. And these are the tuned parameters, or should be at least the tuned parameters from a hyperparameter sweep. And this will be done in 5 minutes. So what I'm going to do is I'm going to go grab my window from wherever it's blown halfway down the street, and then I'm going to be right back, and then we're going to do the same exact thing with Space Invaders, and then we're going to launch some like large scale experiments to figure out which of these environments we need to improve on the most. I'll be right back. Okay. Literally blew a screen out of the window. Well, that looks like a good reward. That looks very good. So that is what's that? 6.7 million steps worth of C-quest in 5 minutes. It can go substantially faster than that. I'm assuming it found slow hyperparameters like that end up actually being better training throughput, even though it's lower SPS. And then now the additional time at the end there was it running a overall evaluation. And there we go. Now we have our C-quest baseline. So we'll go look at that one, but let's queue up Space Invaders while we do. Okay, interesting. Right here. This is why our run crashed before. There's a comma. Okay. And there it goes. So, be done in 6 minutes. And we will look in the meantime at wand B here. Space Invaders. Hey, Joseph, how can I be best grad student, master's, RA, for a PhD student or professor I possibly can be? Wait, how can I be the best master? Okay. I didn't know that they do RAs as masters for PhD students. That's kind of odd. Start school in 3. I mean, it depends how much RL you know, right? Depends how much RL you know going in. How much engineering you know, what skills you have, that sort of a thing. Yeah, so these baselines definitely need to be fixed. We need to add like a max cost or whatever to these. Sequest is very nice. Space Invaders is possibly training. Oh yeah, you can see it's starting to train here. It's going up. It's a hard game as well. It's kind of funny. It's This one takes a long time, doesn't it? Oh, because it's 18 million steps, I guess. What's this? Pong and breakout, I guess? All the way down there. We have to understand why breakout is doing that. So we'll have to look at some environments. So this gives us our baselines at the very least. Let's go look at our sweeps. See if I can find the carb sweeps for breakout. Oh, here you go. It's the best ones we got were like 2100 score. Let's go see. Do we match that on our... Yeah, we matched that on Sequest, didn't we? Yeah, 2100. Perfect. So our Sequest baseline's very good. Space Invaders, we're looking for 550, I believe. That could be made better. Qbert got as high as 2900. Pretty good. Pretty close, yeah. Oops, same one. Beam Rider, we got close to 1800. Beam Rider has a very, very nice curve on it. It's pretty close with our eval. Pretty close. Within a reasonable margin of error, I'd say. Duro, can we find our breakout sweep? I'd like to figure out what went wrong with our breakout sweep more than anything. Is this the MOBA? Yeah, it's a MOBA. We don't need this one for now. Maybe this one? Okay, cool. Here's breakout. So, interesting that this was getting better, but I think it just got skewed so poorly by this. We should just rerun the breakout sweep, right? Potentially with more... Yeah, potentially with more settings as well. What's the Pareto front look like for this? Mm-hmm. Yeah, so it's all these, like, I think this run just screwed it up. We should just rerun the breakout sweep with substantially more samples. Is this finished? Yes. And what did we get for Space Invaders? 539. Okay, that's about what we were expecting. So we're going to make a couple quick changes to some stuff in dev here based on the findings from some recent Atari stuff. Let me see. So I kind of want to add like a max cost param. Is there a max cost? I thought that there was a, here it is, right? Config. This it? Max suggestion cost. So we could add this. We say we have each environment train in an hour. Okay. Args here. Let's see if this is a valid parameter. So what I'm doing at the moment here is key error max suggestion. Okay, so we have to figure out what the heck happened there. We'll put the breakpoint up here. So what I'm doing now is I don't want to limit the model to a specific number of samples, because let's say that your experiment gets up towards the maximum number of samples, then it's going to start finding slower and slower configurations that keep like using those same samples over and over, instead of just cranking up more samples. So what I want to do instead is I want to be able to have it have like a ton of samples, but it's not going to suggest an experiment that should take longer than an hour. That's what I'm trying to do at the moment. And reason for that will become clear in a moment. Okay, there it is. Oops. Bufferlib. Okay, so now we have a suggestion cost here. And up to 200 million steps, I believe. Do more than that? Hold on. Let me just make sure I have the right order of magnitude. So 30,000 times 3,600. Fine. Okay, it's like 100 million anyways. So the most that it would be able to do anyways is like 100 million. So this is now going to cap it to roughly an hour of cost. And should be able to estimate this pretty accurately. Yeah, and there we go. Here are our settings. So we're going to see whether this does better. We've made some substantial improvements to our carbs integration since we last did our breakout sweep. I think the biggest improvement has been that we just have much more accurate evaluations, and carbs relies pretty heavily on having an accurate evaluation of how good the model it actually trained is, right? It needs to know that in order to decide whether it was a good experiment or not. That was a pretty noisy estimate previously, but now it should be much more stable. So Python demo env breakout sweep carbs. Oops. We also want to know how many experiments to run, right? I've been trying to figure out how many I want to run. You know, these do get to be pretty chunky. I think it needs to be more than 100 though. I think you set it to... I think I set it like this and we just see what happens. Okay. Python demo and breakout. Sweep carbs. Okay. And this gives us... Perfect. And now we can make these improvements. So we fix Space Invaders. We increase the maximum run length for Atari. We fix a few things with carbs in the demo. And we also add the max suggestion cost to default. Okay. And here, we now can see that we have some nice new Atari baselines. And what we're going to do is we're going to do process time. Let's put this into like a reasonable size. There you go. We should just double check the original PPO paper. For Sequest. Just to make sure we're actually doing well. Sequest and Space Invaders. So here's Space Invaders. And then Sequest. We actually are already better than Sequest. Beam Rider. Oh yeah, we're beating them on a lot of these M's already. Yeah, we already beat Sequest as well. That's crazy. Was it 200 mil? Shoot, I forgot. The 200 mil? Oops. Where were their Atari results? Table 5. 40 million game frames. Do they say how many they don't say how many. How long do they train for? Oh, it is 40 million frames. Okay. Cool. So that's nice. I've wanted these for a while. We need to have like longer runs of these so you can see if you keep running them how much better you can do. I think that should come out of our benchmarks, I would hope. So here's carbs, right? Oops, where'd it go? Sweeps. Okay, here's our carb sweep. This is now going to run massive sweep on breakout. You can see like here, right? What it's going to find. It's going to run like 14, 16 random experiments, something like that. And then after that, it's going to use the algorithm to attempt to find better hyperparameters. I'm going to probably let this run like all weekend. Yeah. And then hopefully this is going to give us a very nice training curve, a very nice hyperparam sweep curve, and we'll be able to pick some good curves based on that. That'll be good. Let me just check if that's something important or if that is a spam message. Place your bets. Oops. One, 2 spam messages, 3 spam messages, 4 spam messages. Hold on. Who's this? August 2022. This is cool. Interesting. They do LM stuff. That's cool. Okay. Well, we've got these running. What time is it? It's 5. I think I probably should. Well, we'll do a couple more things before I'm going to have to take a little bit of time to write a rebuttal before it gets too late, so I can submit some material to NeurIPS. And yeah, we'll see from there. I think I might stream tomorrow. I might not. We'll see. I don't know how interested folks will be. It'll just be I need to clean up a bunch of the C code. Just need to grind through that, and hopefully like have like a single file thing to ship. I'm still figuring out what format I want that to be playable in. Yeah. Oh, I should also just double check if I have anything I've heard back on the GPU end. Probably not. It's already like pretty late in New York time. It actually takes like 6 clicks to launch Slack in your browser. Delete everything and run. Okay, I've been told that I need to build from scratch. So I have this sweep running already, which is a little bit unfortunate. I think I'll kill this sweep for now. It's only been running for a little bit. I'm gonna fix the GPU drive stuff, and then I'll launch this sweep again before I end here. Yeah, let's do that. It's cool that it's already finding reasonable policies, though. Let me see. So if you haven't heard of this already, this will be the last thing we'll do today. If you guys haven't heard of this env already, GPU drive it's a pretty cool sim. It's been taking off. Just recently released. And we have really fast bindings for it in Puffer. But there are some things that are screwy with it, so we're going to look at fixing that. Dir build. Make -j. Yeah, there we go. That has to do some stuff, right? They'll be good. Okay, this gives us the library. That should just disable any weird caching going on. We'll see. It no longer seg faults. No longer seg faults. That's awesome. So I guess we do have to run a little sweep on this then. $10 million steps, 25 million steps. Do this. Tmux. Let's sweep carbs. Back native. So hopefully that does something. And then I'll just, what I'll do is I'll probably finish up here. If anybody has any RL questions, I can answer a few things. But otherwise, I will let this run. And then I'm going to go do the rebuttal shenanigans. And then hopefully we'll have some runs done for this by now, because these are fast. And then I will be able to do, from there, run the breakout sweep, and I'll be doing some C stuff tomorrow. Maybe stream, maybe not, we'll see. This looks good. I may as well let this run finish, because I want to make sure that this actually works. You can see GPU drive, the binding is very fast. It's about 5 times faster than it was originally. Puffer did some puffer magic. See? No file checkpoints. What happened here? Huh? Let's see. Let's see if that happens again. For folks on YouTube, all the stuff I've been working on, it's been a little slower lately, but we're going to be back on the MOBA as soon as I finish this C demo. That'll be fun. So probably Monday. And all the stuff I've been working on, it's all free, open source, nice and simple. Most of it's in the dev branch here. I'll post the repo, but if you want to help me out for free, just star it. That's all you got to do. Helps me out a ton. 8:04 today, dang. Almost 4.4 on the Twitter as well. Good metrics. Okay, let's see if we still get this bug. Pi agent. Save to file. No file. How is that possible? I've never seen that before when checkpoints / carbs experiment, right? Checkpoints. Yeah. It's really weird. Huh. Let's try this. We don't really need to, we don't ever save those anyways, right? Okay, we'll see whether this does it. That should be nice and stable, but we'll see. It's good train speed. We'll see whether this env is, the env binding is correct. If not, I'll have to mess with that over the weekend as well. Ugh. Still set CUDA heap size. Okay, well. Um. Well, we do get to run our breakout sweep as a result. And breakout, mode sweep carbs, vec multi-processing. There we go. $25K. All right. It's 5. I am going to go take like an hour to go fix up and submit a rebuttal. Hey man, your thesis defense was really cool. Thank you. I'm now graduated and free from the shackles of academia, meaning I get to do a ton of really awesome reinforcement learning dev live and really just try to fix the field. So much of the stuff of my PhD I've already just like blown out of the water with just the level of performance we're getting in Puffer. I don't know if you've seen any of the recent stuff. Oh, here. I guess I'll show this because I'm proud of this. We just got this running today. So here's a snake game. This runs at like 10 million steps per second single thread. And what you're seeing now is like 100 snakes or whatever running live on one CPU core with reinforcement learned policies all in pure C. So the environment is C, the renderer is C, and the policy forward is C, meaning that this is going to go on the website soon and you're going to be able to play with these guys. So yeah, we've been doing some fun stuff. Just finally got this working today. Yeah. I know, I think what's going to happen with reinforcement learning, with the stuff I've been doing lately, is just like automated hundreds of experiments that run overnight and just ultra fast simulators for all of RL. What's the plan? These things are pretty fun to watch. Technically, I think I'm technically able to play this as well if I can figure out which agent I am on the board. Oh, I can see it. I'm the red one at the top right. Unfortunately, they have perfect reflexes, so unlike Slither, it's very hard to foul them up. Quite far above my knowledge level, but this stuff is still cool. Yeah, I'm gonna make a more semi-accessible video on some RL stuff, like another long form video. I have it in the works. I have to do it, and it's so much work. There's so many things I need to do. There's only so much time. But it's been going well. It's definitely been going well. Really, all I want to do is code lots more sims. We'll see. Anyways, I gotta call this because I have NeurIPS rebuttals to finish tonight. So, technically, I've done the ones for the Pufferlib paper. We got shredded in review. We got 663 on Puffer, which is insane. But I have one other one that I am obligated to finish today, so I'm gonna go do that. And I might stream tomorrow, but I'll definitely be back Monday. So thanks for dropping by. If you want to check out any of my latest work, it is all in Pufferlib, which is right. I'll link it one last time. Puffer's right here. Feed the Puffer a star on your way in, if you please. Helps me out a bunch. And yeah, see you around.